My talk is called Context-Driven Test Automation, how to build the system that you really need. I'd like to start with a little bit of background and where the idea for this talk came from. Back in January of this year, I was asked to lead a team to examine all of the test automation tools that we had. F5 Network has a lot of different products, and a lot of the product teams had built their own test automation systems. And we wanted to take an inventory and try to figure out where do we have overlap, where do we have gaps, and how can we avoid duplication of effort as we're expanding our tool set going forward. So we looked at 11 different automation systems that were being used around the company, and we talked about the capabilities of all of these systems. And we saw that there were common tasks. There were basically 6 common tasks that all of these tools had to deal with. You had to have some way of organizing and distributing your tests and controlling what tests run. You had to have some way of setting up your test case. The thing that absolutely everybody had to do and had to handle in their tool, to configure F5's products, the first thing you have to do is log in. So in order to do any test, you had to log into the box. Your test case needed to have a user ID, password, and an admin IP address so that you could find the box out there and log into it. So they all had some way of getting this information. Then you have to actually execute the test. You have to evaluate the results. You have to do some sort of tear down and clean up. And then you need reporting. All of the tools had the ability to send out email and show you what the results were of this test run. And the CTO was not really happy when he learned that we had written that piece of code 11 different times and we're maintaining it at 11 different places. So then we spent some time talking about all of these tasks. Test distribution and run control. Some of the tools were pretty sophisticated about this. They could say, there was data within the test, and the test framework had the ability to look at that data and say, this particular test can run on this piece of hardware and this piece of code, and this release of the software, but it can't run on this piece of hardware. So if I'm running on this piece of hardware, I'm going to skip that test. Other tools had no real way of doing that automatically. You had to go in and manually edit the set of test cases that you were going to run. Setup and tear down. Similarly, there was a pretty big range. Some of the tools took care of a lot of the work in setting up and configuring the box and getting it into a particular state before you ran the test. And some of them left everything to the test case. Test execution and verification. For the most part, all of the tools left the actual execution of the test to the test case and the test writer. There is one tool that has some capability for data-driven tests. You define the data set, and then the tool writes the actual executable code. But for the most part, that was left to the test writer. And verification was another spot, again, where there was a lot of variation. For some of the tools, it was very simple to tell whether or not a test had passed. You checked a single return code, or you looked at a single value in the database. Other tools and other tests were very complex. You had to analyze multiple streams of HTTP traffic, or even look down and grab individual packets from the network flow to figure out if the test had actually run successfully. And reporting, as I mentioned, everybody had a system for emailing out results when the tests were done. Some of the tests had web GUIs for examining the results, looking at historical results, looking at trends, and some didn't. Some didn't bother with that. And then, so far so good. We all agree that these tasks, these are the tasks that matter, that we're all doing. And when we started trying to discuss the relative importance of the tasks and what we should work on next and how we could share and what requirements were, we started to argue about things, and that really surprised me. I thought we're all doing test automation here. We're all doing basically the same thing. So this should be easy to agree on. It really wasn't. We didn't agree on how you should store results. Some tools used a database and kept a lot of detailed information. Some tools didn't save anything. All they had was a text file with a bunch of pass-fail results. We didn't agree on the proper scope of an automation framework. Some tools provided a lot of helper functions and made it much easier for the test writer to write his test case. Other tools provided almost nothing. All they would do was execute the tests. And there was one developer who said that, one tool developer who said these test cases that your system has provided a lot of help to, these are terrible because now that test is wedded to the framework. You can't run it outside the framework. And the first thing I do when a test fails is I take it and I go over to the developer and I run it on his hardware. So you guys have screwed everything up by doing it this way. And for me, my personal breakthrough on this, the moment when the light bulb came on, was in an email conversation where the developer said his test has to run outside the tool. That's his #1 requirement. And I looked at that email and I thought, what are you talking about? That's not a requirement. I don't need that. And I had to stop and take a step back. His tool has been in production use for a year. They're very happy with it. It ain't my job to tell him that's not a requirement. So I had to stop and think about this. And I realized that we were doing different things. We were approaching the problem of test automation from slightly different directions with slightly different intentions. We had different contexts for the problem. And once I realized that we were trying to do different things rather than the same thing, then no wonder we don't agree. So we talked about this fact, and we kind of all took a step back and looked at the problem from a higher level. What were each of the teams trying to accomplish with the different tools that they had built? And as we started looking at this and thinking about the context, we came up with a few questions that really seemed to be key to determining what your context was and what your tool was going to do and how it should work. The first question is, who's writing these tests? What do they know how to do? What is their day-to-day workflow, and how does writing tests fit into what they do every day, and how does looking at test results fit into what they do? The second question is, who's looking at the results? Is it just the people writing the tests, or are there other people looking at it? What other information do they need to go with the test results? What level of detail are they looking for? The third question, what decisions do these results influence? This was something that we didn't talk about originally, but became clear to me a few months later. As we were getting close to a major release point, we were taking code that was being developed by different product teams in different countries on different code branches and having to integrate them all together. And we chose to use a couple of these test automation tools as quality gates. So you had to pass on the XBBT before you could merge your branch into the trunk. So that was a decision that was being influenced by the results that came out of a tool. And looking at all of these things and the tools that we had built and were using, we came up with 4 contexts that we're using in our setting. And we called these contexts the individual developer context, the development team context, the project context, and the product line context. At the individual developer context, the tests are being written by developers. The developers are the ones that are looking at the test results. And the primary decision that we're influencing there is code check-in. If the tests don't pass, you don't check that code in. The next context is the development team context. And at this context, the tests may be written by developers or testers. The developers and the testers are probably both looking at the results, and you may have program or project managers looking at them also. And this is used to decide whether or not to merge a branch and where we are in terms of being ready for a release. So you have to pass these tests in order to do a release. The third context is what we call the project context. And in my experience, this is kind of the default context. This is what people are usually talking about when they talk about test automation. And that's what tripped us up. Most of the people in this group were testers and test managers, and we were thinking about the kinds of automation we write, and we assumed everybody was talking about project context automation. But there were some developers on the team that were talking about other contexts. And if it hadn't been for them, we wouldn't have had the initial problems in having a conversation, but we would not have realized some of the things that we figured out later. At the project level, the tests are written by the testers, they're looked at by the testers, and you use them to see, have we met our project milestones yet, and are we ready for release? And finally, there's what we call the product line context. And The distinguishing trait of product line is that you're testing code that's already been released. It's out in the wild, in production use. These tests are typically written by testers. The results are looked at by testers, by program managers, sometimes by senior management. And you're using these tests to gate patches and updates and maintenance releases. One of the interesting things that we saw was the tests often are useful in multiple contexts. So you may use the same test at the development team level, at the project level, and at the product line level. And the difference really is the framework that you're using to control how those tests are run, when they're run, and what kind of reporting you do on the tests. So let's talk about some questions, specific questions you might be trying to answer. So, will the refactoring I just finished break anything? This is the kind of question that you're trying to answer with your individual developer automation. We actually didn't spend a whole lot of time talking about this because, as I mentioned, most of the people in the task force were testers and test managers, and we don't have as much experience dealing with this kind of test. But the most common example is unit tests, JUnit and unit, whatever technology you're using. Characteristics of these, they need to be very fast. Ideally, every time you save your code, you're running these tests again. So they've got to come back with an answer in seconds or no one's going to bother. You're testing some very small, discrete piece of functionality. You may be testing a single procedure in an API. Writing these tests, you really have to know the internals of the code. And these tests should be considered part of the code deliverable. If you haven't written these tests and delivered them, you're not done with your code yet. There's a lot of good literature about this. I personally am a big fan of Gerard Mazzaro's book, XUnit Test Patterns, for figuring out how to handle these kinds of tests. So another question you might be trying to answer, if we merge our feature branch to main, are we going to break anything? And this is the development team context. These tests, usually you're focused on a particular subsystem, particular kind of functionality in the system. They still need to be fast, but they don't need to run in seconds. It's nice if you can, but they don't have to. You won't fail to meet your goals that way. These tests may go through the user interface that's accessible to your customers, or they may use an interface that's not directly available to the product users. Writing these tests, you don't have to know as much about the internals of the code, but you do usually need to know a lot about the protocol or feature areas that are being tested. And once these tests have been implemented, it's usually pretty easy to migrate these up to product and project tests. My team, we maintain a build verification test that was originally built by one of the development teams in our organization. And these tests are oriented towards finding particular types of race condition bugs that are really difficult to isolate. And they wrote this test. Back when they designed the system, we were doing builds. We were doing daily builds so they could run the test against every build as it came out and know this bug was introduced yesterday. So get the list of check-ins that came yesterday, and this bug is in there somewhere. Since then, we've switched to continuous integration. Now we do builds every 5 minutes sometimes. We're not able to run it against every build, but we do run it as many times as we can so that we've managed to narrow down the slice in which you're going to find that bug even more tightly. Are the builds of our product becoming more stable or less stable? This is a question that you would address using project context automation. In the project context, you're focused on the user-level behaviors of the system. Speed is always desirable, but again, it's not essential or not as essential at this level. Now, we typically run these on a daily basis. Your infrastructure is more complex now. Now you're having to think about things like hardware dependencies, operating system dependencies, browsers, multiple language support maybe. Another complication that we've run into is that we typically are using these tests against multiple projects and against multiple releases. So we may have a test that passes against version 7.4.2, but it fails on 7.4.3, and then it passes again on 7.4.4. That fix got pushed out from 7.4.3 to 7.4.4. So the tools have to have some way of handling that level of variation. Reporting becomes much more important at this level. You'll typically have project managers and even senior management wanting to know about the results here. You know, they're thinking this is an indicator of the state of the software right now and how close we are to being able to release this. Graphical tools that can show trends are very useful. We've built tools that let us drill down. You know, you start with the top level results and you can drill down to very low levels of detail and look at the standard out, standard error, and log files for any particular test that you're interested in. And finally, the last question, will this patch work for customers that are running the basic, professional, and premier editions of the product using service packs 1, 2, or 3? And this is a product line context question. So again, product line, you know, you're testing code that is already out there in the field. Sometimes these tests are very long. You know, my team maintains a tool called the long-term stability test. And we take, as soon as a release is approved, before it's made available to customers, we take that code and we put it in the long-term stability test, and we run tests that are designed to, to push as much traffic through as possible and expose any memory leaks. Now, we have cases where we ran it for 97 days, and then we got an out-of-memory error. It'd be nice to be able to run those tests faster, but we haven't been able to figure out a way to do that. You know, you push traffic through at line rate, you can't push it through any faster. Your goal here is to ensure that your hotfix release or your patch, it will fix the problem you said it was going to fix, and it won't cause some other problem and break something else. False results can cost you a lot here in terms of your reputation with your customers. So reliability is a big deal on these kinds of tests. We find that these tests can be very challenging to maintain. You know, you may have tests that go back 4 or 5 years, tests where the person who wrote the test isn't at the company anymore, the person who wrote the feature isn't at the company anymore. So you need to make these tests as clear as you can so that when somebody goes to look at this code, when no one's looked at it for years, you can make sense out of it. And run control is a huge effort here. You know, you only want to run the tests that are valid for the particular combination of hardware, software release, service packs, patches. If you want to run only the tests that are valid for this particular configuration and not the other tests, because again, you are at much higher risk of false failures or false positives that way. So now I'd like to look at a couple of case studies of tools that we built and how they address the problems of the different contexts. The first tool that we'll look at is a tool called the ITE, Integrated Test Environment. This is the tool that my team has built and is our primary responsibility. The ITE is built on top of Staff and Stacks, so I'd like to thank Alfred for giving that little introduction about Staff and Stacks yesterday, so I don't have to talk about that quite as much. Now, as Alfred said, you know, Staff is an open source framework. It was originally developed at IBM. It provides a lot of different capabilities that are made available as services that can be used across platforms by different operating systems and different programming languages. The ITE was developed by testers for testers, and you know, we hoped the developers would like it and use it too, but that really wasn't the primary target. We've written a lot of code for the system in Python in addition to the Stacks code, and we encourage people that are writing tests to run within the ITE to use Python, but we support a lot of other languages. There are tests in it that are written in C, written in Perl, written in Java, even some shell script stuff. The primary design criteria for the ITE were to make completely hands-off execution, so you could run it in a lab and it would just run and nobody would have to go check on it or babysit it, go in and hit return at the end of a run. to give the test harness the capability to figure out which tests were valid and which tests they should run. All of our tests are tagged with metadata that describe the versions of the hardware that the tests are valid for and the releases of the code, releases of the product code that the tests are valid for. And finally, to provide services and reduce the burden on test case writers, especially in terms of setup and teardown, which can be fairly complicated given our products. Now, F5, our organization, has not emphasized, historically has not really emphasized development skills in hiring testers, so we couldn't assume that the testers were going to have really strong coding skills, so we provided tools to make it easier for them. Over the last year or so, we have shifted. We're looking for strong scripting skills now when we hire testers. And the kind of the overall design goal of the ITE was that you'd be able to fire off a test run when you leave at night, and when you come in the morning, you'll be able to look at your results and have a good sense of what the current state of the product is. So now I'm going to talk a little bit about how the 6 tasks are addressed within the ITE. So distribution and runtime control. The tests and the system code are all stored in source control. We make the tool available as a Linux chroot. All the tests all the test dependencies and all the framework dependencies are contained inside this chroot. So you start up the chroot and you've got everything you need. You don't have to go grab anything from some other source. We provide a tool within the chroot so that you can you can grab updated test cases without having to go out. Everything is stored in source control, and as I mentioned, the tests are tagged with metadata of various types to allow us to control runs. And we're looking at ways to tag the tests so that, if you've made changes to the compression code, you can grab only the compression-related tests. If we tag them with various properties, that'll make it easier to define a run and only run the specific test that you care about and not have to take the time to run everything. Test setup. So in keeping with our goal of easing the burden on the test case writers, we provide some tools to help you configure the device under test. We also provide tools to configure an Apache web server that is very commonly used in our tests, and to configure some other test services that you might want to use. Execution. We do provide some limited data-driven capabilities. So you can define a data set. Those data sets get stored as XML, and then at runtime, we parse the XML and generate the executable Python code. That tool is fairly immature right now and isn't used widely. So for the most part, execution is left to the test writer. You have to figure out how to make your test happen. Verification. This is another area that's left largely to the test writer, although we do perform some health checks and look for core files. So if your test, if your test causes a really serious error, we'll pick that up for you. You don't have to do as extensive checks for that. Teardown. We group our tests into what we call subjobs, which is basically a directory folder that's got some arbitrary collection of related tests. And as each subjob is completed, we do a fairly extensive cleanup of the box and make sure that we get back into a known state. Results reporting. So we send an email that says this many tests were run, this many passed, this many failed, this many aborted. We use an abort state that indicates that we were not able to configure the box the way you wanted it, so we didn't try to run your test. And then we have more detailed links in there. We provide that same data for each subjob and list which tests were in and which tests passed and which tests failed. We also have web pages for looking at these results. We have a database behind those web pages where we stored all the results from every run we've done in the last 2.5 years. So hundreds of test runs, hundreds of thousands of test results. The web page has drill down links, so in 3 mouse clicks you can go from the top level that 97% of the test passed. With 3 clicks you'll get down to looking at standard out, standard error, and log files from a particular test that you're interested in. The second tool I'd like to talk about is a tool called the XBBT. So the XBBT is written in Perl. It was developed by a developer for use by other developers with testers as a secondary target. both the ITE and the XBBT were written before we had these conversations and came up with this idea of contexts, where the ITE is really aimed at the project and product line context. The XBBT is aimed at the development team context. So design criteria for the XBBT. The test should be able to run inside or outside the tool without any modification. And the developer wanted to impose as little overhead as possible on the test writers and as little overhead as possible on running the test. So you should be able to run these tests on any box you have and not have to worry that it doesn't have this package or that package installed. Now, the XBBT provides many fewer services than the ITE does, but in return, it imposes much less structure and much less overhead on you when you're writing your tests. So how does the XBBT handle the 6 tasks? So distribution and runtime control. The tests are all stored in source control, and they're stored in the product code branch. So to get the right test for the version of the product that you're testing, you just get them directly out of the source control for that project. There's no matching, there's no matching of test cases, no matching within the tool of test cases to versions of the product. Runtime control is done by what are referred to as test manifests, which are basically XML files listing the tests. These manifests can be nested to arbitrary depths. I think the deepest he's got running right now is about 4 levels. If you want to run some tests but not the other tests, you have to go in and manually edit these manifests and comment out the tests that you're not interested in for this run. Setup, the XBBT provides the login credentials and the IP address for the box and passes those on to each test case, and then the test is responsible for all other configuration issues. Test execution is left for the test writer to take care of. Results verification, again, is left to the test writer. Tear down is left to the test case. The expectation is that every test will clean up completely after it's done and leave the system exactly the way it was prior to the test. Reporting, as the XBBT runs, it writes to a text file at the end of each test with its pass-fail results. At the end of the run, these text files get mailed out. They're also stored up on a web server so that you can go look at the web page and see all of the text files from all the various runs. There is no database, so if you want to find out what happened with this test yesterday, you have to go up, you go up to the web page, you have to search until you find the day and time that you're interested in for a particular run, and then search through that file yourself to find the test result. So what did I learn doing all of this? The first thing and the biggest lesson for me, back when we disagreed and we couldn't agree about what was important in a test framework and what the best ways to solve these things were, nobody was wrong. We were all right for the individual problem that we were trying to solve. There are lots of different approaches to doing test automation. Most of them will work. There are approaches that don't work for anybody, but mostly, your ideas will work. The one that's going to work best for you in your individual circumstances is going to depend on who writes your tests, who's building your framework, who's looking at your results, and what decisions you're trying to make. The thing that we've done, what we've taken away from this is rather than try to build one framework to test them all, we're now focusing on building shareable components. The staff framework is a great model for this. It already had everything set up as individual shareable services that are cross-platform, cross-language. So we are looking at ways that when we're building features, building new functionality that is of interest to more than one team, we can provide that as a staff service. Some examples of things that we're doing. Right now, each of the product teams has their own smoke test, and there's one team that has 2 smoke tests. So rather than try to get everybody to agree, all right, your smoke test should all run in this one tool, we've written a simple CGI script that everybody's tool can submit their results to, and you can see it all on one page. Our next step, taking it one step, that idea one step further, is to write a staff service that'll allow you to submit results, so that anybody who writes a tool or anybody who's got a tool, they'll be able to submit their results. We'll put them in one reporting tool and one GUI, and when you want to see the current state of a build, you'll be able to look at all of the different modules and components all in one place. One of the things we found when we were looking at all the tools, there were 5 different web GUIs, so a lot of work had gone into that, but nobody was really happy with what they had. Everybody had a list of things they wanted to add, ways they could make their GUI better. A lot of them reminded me of the things that James Whitaker was talking about yesterday in terms of visualization. We really want to be able to see what's the current state of our software and our test. That's a lot more likely to happen if we can concentrate all our resources on one GUI rather than writing 5 or 6 or even 11 different GUIs. So, what good does this do you? And back on my first slide, I told you that I was going to help you figure out how to build the system that you really need. And to do that, you've got to figure out what your context is. So who is going to write and maintain your framework? If you can have dedicated people or dedicated team to maintain your automation framework, you can build a much more capable framework than if it's going to have to be maintained by a tester who's going to be doing this as a side project in his spare time in between trying to get his major releases out. Who's going to build and maintain the tests that are running within this framework? The more skilled your test writers are, the less they need help from the framework to make all the tests work. So if you've got highly skilled developers writing your tests, maybe your framework doesn't need to be as complex as if you've got people with lower levels of development skills. How are you going to use the tests? If you're going to use your tests to gate check-ins, the tests have got to be really quick. If you're going to use them to validate new builds, they can take longer. The BBT that my team builds takes about 90 minutes to run. The first 30 minutes go for installing the product. It takes 30 minutes to do a full install of the product, and then the tests run for about an hour. That was great when we were only doing builds once a day. Now that we've got continuous integration, and sometimes we've got builds coming out every 10 minutes on 15 different branches that all want to have the BBT run, it's become a bottleneck. We've gone from 1 machine to 6 machines, and we still can't keep up on days when there's a lot of code being checked in. So what we're doing to solve that problem, we're now separating out the tasks. So we have a separate, well, we don't have it yet, but we're building a separate tool that will test nothing but installs, and then if those installs pass, we spin up a virtual machine and do the hours worth of tests on a system that we know will install correctly. One of the problems that we've run into is that our installer tends to be a little bit flaky, especially in certain phases of the development cycle. So we would do an install to run the BBT, and the install would fail, and then somebody would have to go and recover that box. So moving to virtual machines, virtualization, another of James's points, by moving to a virtualized system, if something goes wrong in the test, we just snapshot it to look at later and shut it down, and we haven't wasted half an hour, and we don't have to waste another 15 minutes recovering that box to a usable state. And the final question, ask yourself, how long are these tests going to live? If these tests are only going to be used for one short-term project, you don't need to put a lot of work into how you're going to control the runtime execution of the tests. But if these tests might live for 5 years or 10 years, if you've got a 10-year product lifetime like Microsoft's does, you're going to run into cases where these tests are going to work on some versions, they're not going to work on other versions, they're going to have to be tweaked to work with one service pack or another service pack, and you'll need ways to control and say, this version, I want to run this version of the test if we've got Service Pack 1 installed, I want to run that version of the test if we've got Service Pack 2 installed. I know that on version 3.5, this test is going to fail, I expect that. Your system has to have some way of handling that variation and those expectations. So in conclusion, wow, I've been talking faster than I usually do. I have more time left than I thought. define your context, know who's going to write the tests, who's going to look at the results, what decisions are your results going to influence, and then think about how the answers to those questions affect your implementation of the 6 actions. And yes, I know I only have 4 bullet points up there for the 6 actions. So if you do all those things, you'll be able to design the system that fits your needs and gives you what you're really trying to do. Solves the problem, the particular problem that you're trying to solve with automation. A few acknowledgements. The only reason I was able to put all this together was I had the opportunity to look at 11 different tools that were solving 11 different problems all at the same time. And there was a lot of work by some very talented engineers building all those tools that enabled me to look and see this. So I'd like to thank the other members of F5's cross-functional tools teams that took the time to demonstrate their tools and explain how they worked. I'd like to thank the members of F5's automated test team. And special thanks to John Hall and Brian DeGeeter, principal test engineers at F5, who took the time to sit with me and take my blob of observations and turn them into a hopefully coherent whole. To Ryan Allen, senior developer at F5, who always challenges all of my assumptions, reminds me that his context is different than mine. He pisses me off in the process sometimes. I end up with a much better set of ideas because of it. And Brian Brannigan, our director of test engineering, who encouraged me to take the time and the energy to write all of this up and submit it to the conference. So with that, I will open up for questions. Yes? Test, so the question is, what is... So the question is, what do I mean by test target? And I think you're interested in tests that would be useful across multiple contexts? Okay. So it was really interesting to me to see John Thomas and Marcus presenting yesterday. Their idea of small, medium, and large tests seems to me to match on some level to my idea of developer tests, development team tests, and project tests. We found in looking at it that there were a number of teams that had built tools that worked, that could be useful at the development team context, at the project context, and at the product line context. And it was largely a matter of which tests and how many tests you were running in a run that determined which of those contexts you were addressing the best. Now, the tests often were identical, and the main issue was how long is it going to take? Are you going to be able to generate the different pieces of information that the different audiences want? Your developers want a different set of information out of a test than your senior executives do. So, to satisfy your developers, you may be able to get away with just a text file that they can grep through to find the results for a particular test. For project managers and senior management, they want to see a graphical tool that shows them a trend line, a past trend line that's going up.
Who is responsible for tagging the simple test?
That is handled, we give that responsibility to the test team, the tester and the test teams. So as an example, we are now using the ITE to do a build verification test. So in the existing build verification tool that my team runs, as I mentioned, it was written by a bunch of developers. It addresses some very specific concerns that they had, but it really didn't fill the test team's need for a build verification test because it only looked at this narrow slice, and as testers, we wanted to see a broad slice. So we've worked with the functional test teams to define a set of tests that give them that broad slice, and we run that within the ITE framework, but it's a very small set of tests and it finishes in an hour. So at that sense, we're using the same tool to address the development team context and the project context. Yeah?
Did you discover any useful lessons about retraining people who've been writing tests for the wrong context, or at least not the context that they want?
We really didn't run into the case where we thought the context that a test had been written for the wrong context. That wasn't a problem that we ran into. We really hit this idea of different contexts not because people were writing tests for a context that didn't work, but because we were trying to agree on how to share components. And when we didn't realize that we had different contexts, we couldn't agree about what was most important. Yep.
You mentioned 2 tool sets for the 4 contexts.
Mm-hmm.
So you were using one of those for multiple contexts?
So we have one product team that has a comprehensive strategy that really addresses all 4 contexts. And they have 2 different tools that they're using. They have one tool that was originally written by one of the developers that is targeted at the individual developer context and the development team context. And the developers write most of their tests using that tool. Then those tests are, those tests are rolled up, and those tests are accessible to the testers also. But for the end-to-end comprehensive tests that the testers have produced for the project and the product line context, they've actually built a different tool. Their tool provides a fairly comprehensive API for generating, and a lot of helper functions for testing their product. They have set it up so that the tools can work, well, they've set up a one-way direction. So the tools that the testers are using have the ability to pick up and execute the tests written by the developers, but they don't really go in the other direction. Yeah?
In those cases where you said that, I guess, verification is responsible of the test writers, but in particular where you have to examine packets, because I think you said in some cases.
Mm-hmm.
The first question is that only peculiar to like a developer test? And then secondly, because they're responsible for the verification writer, do you think about standardizing on how developers might parse the output?
So we have the desire to do packet level captures and tests at the test level to have that be done by both testers and developers. And there are a few testers that are writing automation that works directly at that level. Most of our automation is not at that level. The typical test that runs in the ITE, the tool that my team has built, you log on to the device, you configure some virtual IP or a pool or something, VLAN, and then you send HTTP traffic or FTP traffic or UDP traffic to it. And we look at what comes back in those traffic streams, and we don't get down to grabbing individual packets in the tests that our testers are writing for the most part. Yeah?
You said that the ITE stores results in a database. Do you typically share that database across projects, or is it one database per?
All of the projects that have been tested with the ITE write into a common database. So we have the ability to do data mining. The way the database was originally designed and the way our reporting tools have been designed, right now it's very difficult to look at results for multiple runs. So if we do runs on 3 different versions of hardware for build 37, you have to bring up 3 separate reports to see what happened. And that's that's next thing up on our plate is the ability to aggregate runs. So to generate a single report for build 47 that tells you what happened on all the different platforms. Yeah?
Sort of a detailed implementation question on the ITE.
Mm-hmm.
Was your choice of a true environment because of the specifics of your runtime environment, or do you suppose that, I guess, would virtualization be an alternative that could be used?
So that decision to use the Chroot was made about 2.5 years ago. And at that time, other tools like VMware were not mature enough. And I actually wasn't with the company when that decision was made. But Brian DeGeeter, who was there, sitting right there, you can point out if I'm getting this wrong. That decision was made.
I can tell you the major reason. I mean, we do a lot of packet level testing.
That was my thought.
Virtual network switches do things to packets that can adversely affect tests. So developers wouldn't necessarily take a valid test coming from a virtual switch.
Right. So if you were operating in a world where you didn't have that constraint at the network level, you didn't need to worry about packet level communications tools,
Virtualization is what we're looking at right now. You know, if you look at across the whole range of products, and you know, right now F5 has a bunch of separate products, and we're in the process at the development level of merging all those together so they're just different modules of one product. And they have very different topologies that they work in. You know, we have some products that the basic test harness consists of about 7 different machines. You've got a client, a server, a WAN accelerator, a WAN simulator, a WAN accelerator, a server, and a client, and that's your test harness. In order to make it easier to share those kinds of tests, we are looking at how to virtualize that entire environment as one chunk, so that you could spin that all up as one piece. You know, the discussion yesterday about cloud computing is something that we're interested in, and we're trying to figure out how to do it kind of an internal level. Now, how can we define how can we come up with a schema for defining what a test harness looks like, so that we can then virtualize those test harnesses, and anybody with any tool would be able to say, I need a test harness, you know, I'm running this test, my test harness needs to look like this, and call out to a staff service that can spin up the collection of virtual machines that's needed to test that test. Other questions? Yeah?
Did you find any common difficulties in creating the automation frameworks for different contexts that weren't solved readily by tools that you were building on? Is there any open source?
So open source, then the question is, did we find problems that were difficult to solve, and did we find open source solutions to those problems? Is that your?
Yes, or efficiencies in the open source.
Or did we run into open source tools that couldn't solve the problem? So the ITE and the tools that my team is responsible for, we've used Staff as sort of the backbone. Then some other open source, the major other open source tool that we're using is Python web framework called Django. And we're using that to do all of our reporting UI and to manage our reporting database. And we've also used Django to do our data-driven test. So we have the tool for defining the data sets for data-driven tests that's written in Django. Brian, am I leaving anything else out? Yeah, we use a code review tool called Review Board. That's an open source project that we've been really happy with. We didn't find that we had to make major changes to the open source tools. For the most part, they were pretty easy to adapt to our purposes. Okay. Other questions? Yes?
Systems work well for non-functional tests? Do you end up needing specialized systems still for some non-functional areas like performance and stress testing?
The performance and stress testing is actually not addressed at all within the context of the tools that we were looking at. That's handled by a separate group at F5. And they were invited to participate, but we didn't get a lot of information from them. Yeah, and you know, actually, I think that might be really interesting to see. Is that a separate context, or does that fit in here somehow? And we've had some conversations recently about other contexts. One that we have kind of tentatively identified is what we're calling an experimental context. Now, right now, we're doing proof of concept with Selenium and a commercial test tool called iTest to determine whether or not these tools can automate what we're trying to automate. So that's kind of another context where the question you're really trying to answer is, will this test tool work for what I need to do? Yes?
You mentioned tagging tests as being able to run in certain versions of the product.
Mm-hmm.
Does that mean there's only one kind of place that ITE lives, say, in source control?
Yeah, all the tests are stored in a single, they're stored in one source control tree. We have recently had to, started branching those to make it a little bit easier. That the original concept was all the tests would live in one place.
Yeah, I was curious because a common thing that we've done is as the product gets released, the tests are stored with the source
Mm-hmm.
test as well. So when it branches, then if you need to do a patch, you just go back to that branch.
Mm-hmm.
Those tests were good enough for
Yeah.
the first release, add a test, then run those, and then you don't really need to worry about managing.
Yeah, and that approach was taken by some of the groups that were developing test tools, but it wasn't a particular approach that was taken for the ITE. Okay. Yes?
So how many teams do you have writing tests? You got developers, like you said, you have 3 products.
So, in the product group that I work in, we have a couple of different functional teams that are writing tests, a couple of different functional test teams writing tests that are being added into the ITE that are being used at the project context, the product line context, and now we're starting to use it at the development team context in the smoke test. The developers have a separate set of, they have their own set of unit tests that does not interact with our system at all at the moment. That's something we've been talking with, I've been talking with one of the development managers about that. How can we figure out a way to migrate those, and would it really make sense to migrate those? How much value will we get out of that? Yes?
How do you automate the process of the test along
So the question is, how do we automate the process of the test team's development in the life cycle?
So you are developing development techniques
Mm-hmm.
company
Mm-hmm. So, we have, as part of our development process, we have, when a new requirement is slated to go into a release, a test focal is designated for that requirement, and the test focal is responsible for figuring out how are we going to test this, what are we going to need to do. We have just recently started also designating an automation focal for that requirement. So the automation focal's job is to look at this requirement. Are we going to be able to automate this requirement with the tool set the way it exists right now, or do we need to add additional capabilities into our automation tool so that we'll be ready when this feature is built and we'll be able to write automated tests for it? Does that answer your question? Okay. And Lydia's giving me the signal. Looks like we're
5 minutes.
okay, 5 minutes. Other questions? Yeah.
So how are two tools different when it comes to reproducing a problem and then fixing it? For example, the BBT
Mm-hmm.
seems easier to reproduce a problem than to develop production and fix it, whereas the others are a little more complex.
So the BBT, and in our particular environment right now, the BBT is actually the BBT is a very complicated harness to set up, and we have a few dedicated pieces of hardware that can run the BBT test. So if you need to reproduce a problem on the BBT, if you need to investigate the details of that, we actually have to take that test harness out of production use for the BBT and turn it over to the developers to look at. The ITE is designed to run on individual machines, and it's not very difficult to set it up and run on other machines and connect it to a specific piece of hardware that you need to test. So that's actually a little bit easier to set it up and investigate a problem there. Okay. Yes? It depends on the problem. Sometimes we have all the information we need out of the logs and the core files, and there isn't any further work that's needed. The type of bugs that the BBT was designed to catch are these very deep race condition bugs that are sometimes extremely difficult to track down. And we do have to turn the harness over to the developers, sometimes for a couple of days, for them to figure out what's really going on. Okay. Other questions? Yes? We used XML just for an initial implementation because we understood XML and it was easy to do. We discovered pretty quickly that for a complex data set, XML is a really bad choice. In the words of yesterday's speaker, it's got way too many pointy things and it's really easy to hurt yourself. Okay. Other questions? All right, well, thank you very much for your attention.